Alright, good morning everyone. So today we're gonna deep dive into React documentation. Uh, so in the last video we basically did a quick start, right? And then today we're gonna go further. So basically the React documentation starts from the very scratch and teaches you fundamentals to build any React app. So this is a tutorial on Tic-Tac-Toe, how to build a Tic-Tac-Toe game in React. Right, once you understand enough, then you would have enough idea about uh, basically how to build applications in React, and you will have all the knowledge of the tools that are needed to build any front-end application. So uh, so basically let's just see the tic-tac-toe game, right? We'll just skip this part. Okay, so uh, first the setup is that we basically start with a square component, because in every tic-tac-toe basically we'll have some squares, right? So the square, we have basically defined a function, react component called square, in which there is a button with the class name of square, and the value is x. Okay, so we start very simple, right? So first, to basically do this tutorial in our local environment, we need to install Node.js. Okay, and then we need to install the dependencies. uh, okay, so we'll do npm install, and then we'll do npm start, right? So let's just see the code sandbox, right? uh, so we can just see fork it. So we have a app.js, inside we have a square in that, so we're just rendering an x here. Okay, so code sandbox is basically a platform in which you can run the code and install dependencies. It basically works as your environment in which you can uh, fork out any developer's code, and even you can experiment with your own code, create a new project and run it online with your internet connection. So we'll just go further, right? So let's just see the starter code, right? So in app.js, we have this square component. Okay, so it displays a x with a square button, right? So export basically tells JavaScript to basically we can import this function outside this file anywhere. So then let's just see the styles.css. Okay, so in styles.css we have defined a few reset css, body css, and then some of the simple css's for various elements. And then for the square we have defined that it has a white background, some border, and then some height and some margin, text line center. Okay, then for the board we have some uh, clear css. Okay, and then status. So let's just go further. Okay, so if we see our index.js, we are basically index.js, then we see that we have uh, our style.css and our app that we're rendering in strict mode. So strict mode is basically that your script will run, your React app will run in strict mode. So it will basically render everything twice to see whether the output is correct or not. If the output changes after any render, right? So then from between the first render and the second render, if the output is not same, then it will flag an error. So this is the root document. We created a root element and then we render the entire application inside the root. Okay. So this basically is the main thing. Now let's just see the board. So currently the board is only a single square, but if we need 9 of the squares, then we'll have to copy paste your square to make more squares like this, which is wrong, right? So again, then it is telling us about fragments. This is basically a fragment in which basically if because when you're returning some JSX, then it has to be it has to be wrapped inside some boundary so that it uh, doesn't render multiple children at the same time, because React uh, cannot call multiple functions, cannot return multiple JSX inside the uh, same component. So it has to be wrapped inside one top level JSX uh, fragment. Okay, so let's just see. So for the square, we have updated our square component to look like this. So this is a row of 3 elements, and then another row of 3 elements, and another row of 3 elements. Okay, so now it looks like this: 1 2 3 4 5 6 7 8 9. This is basically looking like a grid of elements. Okay, so now the problem is that our square component is not a square itself, it's a board. So we have renamed our code to look like a board. So we have a board in which we have a row, and we have 3 buttons in every row, and we have 3 rows. So this is a 3 cross 3 board now. Okay, now uh, if we want to change the value of square from empty to x when the user clicks, then we have to basically write some code, right, to make sure that we update the value. So um, first basically we make our component square, and then we also have a square board component. So in our board component we reuse the square 3 times to basically use the power of React, that React can basically have multiple children, right? So every row has 3 squares. Now it looks like this. Okay, but now what we do is we provide a prop to our square component, which is like value. So this value, basically whatever we provide, that will be displayed uh, inside our component. So to display the value, we will wrap it inside curly braces for the button. So now we have an empty board, and whatever value we fill in our board, that will be the value of the uh, square component. So let's say we provide a value of 1 2 3 4 5 6 7 8 9, then our grid becomes a grid of numbers. Okay, so our final code is like this. uh, this is our function square, basically takes a value and renders that value, and then our board is basically a collection of 3 rows, right, and every row has 3 squares. Okay, now once we click some square, we need to make sure that we basically update the value of that square. So now to the button we add a on click handler. Okay, then let's just move further, right? So what basically this does is that every time we click a square, it basically logs clicked to the console, but this is not what we want, so we'll update this code. Okay, so our next step is, so we want our square component to know that it was clicked, and then whenever it was clicked, we need to fill it with an X or a O mark. So to remember things, we use state. So the React has a use state hook, right? So now value is not a prop, rather it's a state of our functional component square. So it stores the value, and then we basically set the value inside it. Also, our square component does not need props anymore, so inside the board we remove all the props. Okay, So now once we define our square, we say that whenever we click on a square, it basically renders a set the value to x. So now what will happen is, once we click on a square, it will change the value to x. Okay. So now our code looks like this. Okay. Now basically React documentation suggests us to understand React dev tools. So with React dev tools, basically we can inspect the props and state of our React components. So it basically uh, in the code sandbox also we have the React dev tools tab. So let's just uh, see this in action in React dev tools code sandbox. Right, so if we click on this, it basically becomes X, right? So now, we see our app component has square and board, and both of them are the UI is looking a bit more interactive than the static UI before, right? uh, okay, next up is uh, reactive tools, right? Now we have our basic building blocks. To make a complete game, we need to basically somehow alternate between x's and o's on the board, and we need to be able to find the winner. So currently our every square component has a fraction, as a part of our game state. Okay. The board will need to know somehow the state of all the 9 square components. So uh, basically uh, the best approach would be basically to store the game state in the parent board component instead of each square, right? And then uh, what we'll do is to communicate between the two components, any other components will have the shared state between their parent component, and then the parent component can basically let the children know that this is the state that you need to work with. Okay. So uh, okay, so our board component is basically a set of squares, and every square is initialized with a null value. Okay, this creates an array of 9 squares, 9 elements, and each of those values is null, right? So at any point of time, our board will look something like a state where every value is either a 0 or either a o or x or null. Okay, so what we do is we say that okay, the square one value is square 0, this is square 1, this is square 2, this is square 3, this is square 4, 5, 6, 7, 8. Okay. Uh, now we will remove the state from the square to basically just render the value, and then now when the square is click, we need to basically call the on square quick. Okay, so this is also a prop of the square click. Okay, now we'll call the handle click function whenever the square changes, right? Okay, so inside the handle click function, what we'll do is we'll say we'll basically take a square copy of the squares, and then we'll set some index of that square to x, right? So Okay, so this is a closure. Basically, this board is a functional component, right? And inside that also we have defined an inner function. So this is the concept of closure, right? So the next square will be a square slice, and then what we'll do is we'll basically set it to x, and then we'll update our squares, right, with the copy of the state after making modifications. So this is what handle click does. Okay, now what we'll do is we'll basically pass the IA to the handle click function. Okay, so currently it was basically updating the zeroth value, but now it will basically have an argument called I to take the index of square to update. Okay, now there is a little bug in this. Basically, uh, so to avoid that, what we'll do is we'll basically say that this is handle click zero. Okay, this is an arrow function. uh, so basically for every square we'll say square 0, and then handle click 0, handle click 1, handle click 2, handle click 3, 4, 5, 6, 7, 8. Okay, so now if we click on any board, right, so now basically our square function is very simple function. It basically has a button and a on click listener to every button, and then a value that it basically renders as per the prop that it receives, right? And then our board maintains the state of squares, and every square will have a value updated to x for now, but we'll basically write some logic to basically determine whether this is an x or a o, right, based on player turn. So this is our board now. If we see the current code in our sandbox, right, then we'll realize that this sandbox is basically much more interactive than what we started with. So now if we click on some element, it basically updates as X. So yeah, we have a shared state at the parent level, which is our board component, because it knows that what each square functionality is, and that we have hard coded in the square component, and that square's functionality is to render a button with an on click listener and a value that it receives, right? And then in the handle click, we basically manage the click of the board. Okay, so now basically our state handling is in the board component, and our board component lets the children square components know that how to render them correctly and how to basically track the state change of the board component, right? So okay, so there is a note that our DOM elements in React, it is a convention that we basically say for an event, we say on click, on change, or on something, right? On touch start or on touch end, to basically denote that okay, something has happened, and then we handle that something as a function to basically represent that handler for the events, right? And we can define our component with any name. So basically it makes sense to call our component a square and the main component to call a board, right? So that we can basically have the functionality written component wise, right? Now let's just understand why do we need immutability. Now once we call handle click, we basically uh, call the dot slice method on our square to basically copy the square, and we do not modify the existing array. So to explain this, we need to understand immutability and why it is important. So generally what happens is that we can mutate our data in two ways. Either we can mutate the reference value exact directly, or we can create a copy of it and then make changes in the copy, and then basically update with replace the element with the copy, right? So React prefers to basically create a copy of the elements, right? So that there are several advantages, like the benefit is that making the state immutable helps you to implement a feature in which you can go back to a certain value which was before the change, right, very easily. If we do a direct data mutation, then we cannot track the previous versions of the data, and we cannot reuse them later. Also, another benefit is that whenever state changes, right, the child components are re-rendered automatically whenever the state of parent component changes. So even if the children components that were not affected by the change will also update. Okay, so the user won't understand it, but we will want to basically not affect performance of our application, and hence re-rendering uh, we can skip, right? So basically with the help of immutability, our components uh, can compare whether the data has changed or not, right? So uh, this basically uh, helps us in the future. We'll talk about memoization. So in that, basically this concept is used that if your data is immutable, then uh, it does not impact the rendering performance of your components, right? Now let's just uh, fill the next logic, right? So now we define a new state in our application to basically say the turn, whether X is next or not. Okay. So anytime a player takes a move, we basically flip this value, right, to determine which player is basically playing on the board. Okay. So basically this boolean is initially true. So then the first turn is of X, right? But then once X has taken its turn, then the next when we flip it here, and then every time the next person clicks, the next click happens, it will be basically O at that point of time, right? So now if we see the code sandbox here, right, with this simple change of adding a new state, we can now uh, yeah, so we can now basically make the board more interactive and look like a real tic-tac-toe, although there are still more changes required. But now we can see that X and O are different, right? So basically our board component manages the turn of the player, right? So with that change, our app is looking more interactive now and more close to our actual tic-tac-toe game. Right. So now how do we know who is the winner? Because we need to know. So basically, uh, so the calculate winner function is basically gonna be uh, taking the squares, right? So if you have the row matching, this is for the rows, this is for the diagonals, and this is for the columns, right? There can be, so basically, to know who is the winner, right? Uh, if we have to figure out who is the winner, we have to basically store the combination of winning, right? So our first combination is first row. If the first row is filled by same square, then we have a winner. If the second row is filled by the same square, if the third row is filled by the same square, then we have a winner. If the diagonal is filled by the same square, if the off diagonal is filled by the same square, then we have a winner, right? Or if we have the column, then we have a winner. So these are the square combinations, and we basically iterate over the lines, and then we say that okay, if the three squares at this positions match, then we say that this is the current winner. Okay, so this function says that if already our square is filled, then we return, uh, and if we have if I have a winner, then we return. Then we don't do anything in our click function. Okay, so now we basically define a status variable, right, to let the player know that okay, this is a winner, right. We basically calculate the winner from the squares, and based on the winner we say that okay, winner is this element, otherwise we say that okay, this is the next player that has to play. So this is a status variable. So now if we fork it, or we can test it here, right. So we say winner is x. If we click further, it doesn't work, right. So now we have a working tic-tac-toe. So looking at the code once again, we see that we have basically a square component which basically has the class name of square and then an on click, and then it renders a value. Then we have a board in which we have two states. One is our squares, set of our squares of 9 elements, and then we basically maintain a state for the turn. Then what we do is we basically have a click handler for every square, which basically takes the square number starting from 0, and it basically determines the winner. Or if it says that there is already a square that is filled, then we basically don't do anything in this click function. Otherwise we create a copy of the squares and we fill the square element with the current player's turn value, and then we update the squares, and then we flip the turn, and then we calculate the winner from the squares in our every time our status updates or our state changes, we calculate the winner and we display as it as a status of the board. Now there is a final exercise that we want to go back into the previous moves in the game. So basically, if we mutated the squares array, implementing our time travel would be very difficult. But since we have used slice to create a new copy after every move and made our array immutable, so we know the every past version of the squares array and navigate between the turns. So we will maintain another array of history, right, which is a 2D array basically. So history represents the board states. So from the first move to the last move, all of the board states will be maintained in history. Now we will basically uh, create a game component to display the list of past moves. In that we will maintain our history state. So this time also from the board component we will lift our state up into the squares, right, and then in the top level game component. So we will create a game component, right. So basically this will render our game board, and then we will render a list of history uh, elements. So since we are making our board component the main component, right. So the current square, so basically now we don't have the uh, so our game state is basically the player turn and then the history of all the moves, and then the current squares. The current square will be the topmost element in the stack of the history stack, right. So think of this history like a stack of the moves that you make. Now we will create a handle play function. So uh, we will pass the x's next and the squares, and the on play function. Okay, now in the board component we will do the handle click, right, and then we will say on play next squares. Now we will implement the handle play function. So whatever are the next square it receives, our history will become the current history plus the current set of squares that it receives. Okay, so now if you see the whole component, let's start with the game component. So the game component maintains the player turn and the history, and the first history is the empty board. And then in the handle play function, we say that okay, whatever was the history, append the new turn, the current set of squares to that. Okay, and then flip the turn. Now our board component will have the squares as the current squares, and on the handling of play, it will basically call this function handle play. Okay, now in the board, what we'll do is, in the board we will basically do the same thing. We won't change anything here, but the next squares will be the square slice, and then on play we will call the next squares, right? So we'll update the history there. So now at this point we'll have a working tic-tac-toe. Now we can show the set of past moves. So since we are since we already have a set of history moves, right? So what we'll do is, we'll say that okay, uh, we'll basically render a move. We'll say that okay, you want to move, go to game start, or you want to go to the current this move number. Okay, so uh, so basically we'll start with the squares, the history, and we'll say jump to this move, and on the click of button we'll basically render that. Okay, so this is our moves list. So now, we'll fill the jump to function. So right, we say, as we keep on adding, our history stack changes, right? And on the jump to function we will implement how to change the move. Okay, so now to implement this feature we will call jump to the move, right? And then also we will provide a key to this element. Okay, to basically not have that warning of keys. Now we have the square, okay, and then we have the board, and then we have the game. Now in the jump to function, what we'll do is we'll set the current move as the next move, okay, and then we'll set the x value to basically next move mod 2 equal to 0, right? Now what will happen is, so after handling the play, what we'll see is that whatever the history is with the current move plus 1, from 0 to current move plus 1, we'll keep the slice of the current history, and then we'll basically add the next squares, and then we'll change the history to the next history, and change the current move to the next history length minus 1, and also X will, right, flip. Now this is what our code looks like. Our current move will be 0, and then from the history current move we'll get the current squares, and whenever we handle a play we will basically change the current move plus 1 and then squares, and the current move will be next history length minus 1. And when we jump to some move we will set the current move, and we will set X, whether X is playing or not will determine by next move mod 2 equal to 0, right? So now we see the game, right? Then we have the, then we can time travel back to any other move, and as we keep on adding moves we will basically time travel. So now we have done one more cleanup, that we make X is next to based on current move mod 2 equal to 0, right? So now we have built our tic-tac-toe, right? So this is how we learn to use programming to build an interactive game like tic-tac-toe in React, which we learned from the React documentation. So now this logic helps us to understand how to build applications like tic-tac-toe as based on the tutorial, right? So I hope you get some sort of knowledge about building React applications from this tutorial. Uh, I'll continue making a playlist series on the React deep deep dive to learn React better. Uh, so basically, this is the sort of this is basically how React illustrates. So I hope now you understand how these concepts helps us implement building an app UI, and then the same concepts will keep on learning to and then revisiting them to understand how React works under the hood and how powerful this library is to build something from scratch, right? So I hope you enjoyed this video, and I'll see you in the next video.